This lecture introduces the Cournot problem that you may have seen before. We're going to keep it really simple, and we're going to optimize a revenue problem rather than a profits problem. Here's the problem. You discover a natural spring on your property. It also flows through your neighbor's property. The demand for natural spring water is given by the simple formula Q equals 100 minus P, where P is the price in cents per bottle, and Q is the number of bottles demanded per day. What is the maximum amount of revenue you can earn per day if your neighbor is not interested in entering this market? We're going to sketch the demand analysis with price on the vertical axis, and with the demand given by Q equals 100 minus P, we can rewrite that as P equals 100 minus Q. We're going to sketch that inverse demand curve starting at P equals 100 on the vertical axis. The marginal revenue curve will slope twice as steeply as the demand curve. So if the inverse demand curve is given by P equals 100 minus Q, the marginal revenue curve will be given by MR equals 100 minus 2Q. We've sketched the marginal revenue curve sloping twice as steeply as the demand curve and passing through 50 on the Q-axis. MR equals 0 will be the point at which we maximize revenue. So we see that the quantity will be 50 and the price will be 50 and the revenue will be 2,500. This is the answer to the question, how much will the first firm make when the second firm is not interested in entering the market? Remember, the problem asks us, how does the answer to part 1 change if your neighbor decides to enter this market? So we assume that firm 1 entered the market in period 1 alone, and the revenue was maximized at P equals 50 and Q equals 50, so the revenue was 2,500, and that was at the midpoint of the linear demand curve. In period 2, firm 2 sees firm 1's profits and decides that it will enter the market, and in doing so, firm 2 views the unmet demand as his market segment. So with the first 50 customers satisfied, firm 2 looks at the second group of 50 customers and asks, how can we maximize revenue given that there are 50 customers whose demand is as yet unmet? Firm 2 sees an opportunity to treat the unmet demand as its potential market, and with the demand Q equals 100 minus P and Q is equal to Q1 plus Q2, or the quantities supplied by both firms, if Q1 is equal to 50, we can determine Q2 as 100 minus P minus Q1, or 100 minus P minus 50, and that gives us Q2 equals 50 minus P. So firm 2 will maximize revenue from this unmet demand and will produce 25 at a price of 25. 25 times 25 yields a revenue of 625. Notice that in the process, because firm 2's quantity adds to firm 1's quantity, the total quantity being supplied is 75, and according to the original demand curve, Qt equals 100 minus P, the quantity of 75 will be supplied only at a price of 25, so both firms are faced with a price of 25, and this means that firm 1, which was selling 50 at a price of 50, is now going to be selling 50 at a price of 25, and this price cut will cut firm 1's revenues from 2,500 to 1,250. So in this graphical analysis, we see the quantity supplied by firm 1 is still at 50, but now the price has fallen to 25, so firm 1's revenues fall from 2,500 to 1,250, and firm 2 has increased its revenue from 0 to 625. Let us move to period 3. Firm 1 is going to retaliate to firm 2's entry, and firm 1 is going to decide that in order to maximize its own revenue, it must view the unmet demand as its demand curve. So firm 1 is going to assume that firm 2 will supply 25. The new demand for firm 1 will be Q1 equals 100 minus P minus Q2, or 75 minus P, and the midpoint on that market segment will be at P equals 37.5 and Q equals 37.5. So 37.5 squared will give us the revenue that firm 1 will make. Notice that in the process, the price has gone up from 25 to 37.5 because the quantity being supplied is smaller at 62.5 rather than 75. And this price hike is going to make firm 2 better off because firm 2 will obtain the higher price without changing its quantity from 25. Firm 2 wins from firm 1's retaliation. So look at our table on the screen. At period 3 will tell us the price is going to be 37.5. The quantity supplied by firm 1 will be 37.5. The quantity supplied by firm 2 is stuck at 25. But notice that the revenues for firm 1 increased from 1250 to 1406.25, and simultaneously the revenue for firm 2 increased from 625 to 937.5. This is because firm 1 has cut back on the quantity it supplied, so the decline in the overall demand is going to boost prices and revenues for firm 2. We can keep the analysis going period after period, but it will take an infinite number of periods before the problem finally settles down. So let us jump to the final solution, and we see that with the to and fro, back and forth of the game, the final settling down of prices will be at P equals 33.3, with each firm supplying 33.3, and therefore the total being supplied is 66.7, and each firm will be earning 33.3 times 33.3, which is 1111.1. Our graphical analysis showing this final solution will be P equals 33.3. The quantity by firm 1 is 33.3. The revenue is 1111.11. And analogously, we can draw the revenues for firm 2 on the same demand curve, because the total quantities being demanded will be 66.7, and they're going to be splitting the quantities and the revenues equally at the end of this process. Notice then that the price fell from 50 to 25. Firm 1's actions brought it back to 33.3 and raised firm 2's revenues in the process. You might be asking, what is the formal way to get directly to this solution of 33.3? We're going to set the problem up to get the long run solution, but we're going to derive it line by line. So we set up the revenue function for firm 1. It's going to be price times Q1. Analogously, the revenue function for firm 2 is going to be price times Q2. We're going to write the demand curve as the inverse demand curve and substitute the P out of the equation. So we'll have R1 equals 100 Q1 minus, and here we have a product, QT Q1. If you wanted to write that out, it would be Q1 times Q1 minus Q2 times Q1. Same sign on the revenue function for firm 2. R2 is equal to 100 minus QT times Q2, or alternatively R2 is equal to 100 Q2 minus Q1 Q2 minus Q2 squared, just like R1 was equal to 100 Q1 minus Q1 squared minus Q1 Q2 if we wrote it out all together. When we differentiate those two functions, we get di R1 on di Q1, which is the marginal revenue for firm 1. It will be 100 minus 2Q1 minus Q2, and the revenue for firm 2 is maximized at di R2 on di Q2 equals 100 minus Q1 minus 2Q2. Remember, this is a revenue function, so when we set equal to 0, we come up with the two equations, 2Q1 plus Q2 equals 100, and Q1 plus 2Q2 equals 100. There is only one solution to this two-equation system because we have two equations and two unknowns, so we know there's a unique solution. The Q1s will cancel when we subtract one equation from the second one. Let us subtract the first equation from the second equation. So we're going to get 1Q2 from 4Q2 equals 3Q2 equals 100 from 200 equals 100. Let me say that again. We'll end up with 3Q2 equals 100. And when we solve for Q2, we obtain Q2 equals 33.333 recurring. If we were to plug that value for Q2 back into either of the two functions, we will come up with the answer that Q1 and Q2 are both identical. 2Q1 plus Q2 is the same as 3Q1. 3Q1 equals 100. That means that Q1 is equal to 33.3, and Q2 also happens to be 33.3. The revenue for each firm will be R1 equals R2 equals 1111.1, and that gives a total revenue of 2222.2. Let us take a look at the payoff matrix here, and this will be a revenue payoff matrix using the same demand curve, Q equals 100 minus P. And we'll assume that firm 1 enters first and produces 50. Firm 2 is sitting on the sideline. From the equation Q equals 100 minus P, if Q is equal to 50, then P must be equal to 50. So we see why we have 50 times 50 equals 2500. Let us assume that firm 2 decides to enter the market and meets half of the unmet demand with 25 potential customers. Firm 2 sets about trying to win some of these customers. So firm 2 brings the price down to 25. So we've moved from the first cell in the first row to the second cell in the first row. Notice that firm 1 will retaliate to firm 2's action. So firm 1's reaction is to increase the price so that at a price of 37.5, firm 1 is going to make 1406.25. And interestingly, firm 2 is going to increase its own revenues from 625 to 937.5. Based on what we said earlier, we've already solved the problem. So after an infinite number of periods, we expect that Q2 will settle down at 33.3, as will Q1, and they will both make the revenues of 1111.1, or a joint revenue of 2222.2. You can see how naive this particular approach is because it has each firm retaliating to the other firm's successive moves, and this means that the firms do not have a long-term strategy. They're allowing the market to guide them towards some kind of solution.